Okay, I'm pretty excited about this next video because it's kind of interesting idea of using linear regression for one-way analysis of variance. We did one-way analysis of variance way back on page 42. That was the null hypothesis that all means were equal. And so here we're going to use linear regression to answer that question. All right, so from page 42, the question was, or do the means of three or more variables differ? And we're going to answer this from the perspective of multiple regression. Okay, so here are the questions of interest. You can find this on page 153 in your yellow course pack. What we have is the data of different grades here. So we have the gender and the major as being business, other, PE, psychology. And here are the scores for the class. This is a kind of made up data from about 12 years ago. And so the question is there any difference by which majors? And then about how much do they differ? So back in page 42, the only thing we could ask is, do they differ at all? But now we'll be able to answer by how much. Here you can look at the box plot scores. Kind of looks like maybe biology and psychology and do other. But so we're going to look for the differences between the centers of the 5 samples. Of course, the centers will never be exactly the same because remember, your data could have been different. And we need to compare the variability between the centers to the variability within the five samples. Hey, that's sounding familiar for what we've talked about there. So back in page 42, the hypothesis can be awkward. So we said either the 5 majors have the same mean score, or at least 2 of the 5 majors have different scores. In other words, mu1 is equal to mu4 equals mu5, and our alternative was at least 2 of the means different. Let's turn this into a regression problem then. Here we have 5 categorical data, so I'm going to use 4 indicator variables to help me out. I'm going to let business majors be the reference variable, and I'm going to say 1 if you're a bio major, 0 if you're not, 1 if you're an other major, 0 if you're not. X3 will be 1 if you're a PE major, 0 if you're out, and X4 for a psych major. X4 will be 1 for a psych major, and X4 will be 0 otherwise. Oh, I should have changed those to 2, 3, and 4. Yeah, made a mistake. Okay, so then rather than using the language of analysis variance that all the means are equal, what we're going to say is our null hypothesis will be all of our partial slopes will be 0. Let's think about that. What we're saying is that the indicators variables add no utility to the model and all the means are the same. And if that's true, the means will all have a mean score of beta naught. If you can kind of think about that, if the means are all going to be the same, so the business majors are all going to be the same as the psych majors, then beta naught will have to be the same for all of them. And so this is kind of a slick idea for how we can use that. So let's kind of go over to our course pack on that particular page. Okay, so here's our model for our example. Maybe get a little bit bigger. So here's the bio majors. That would be if x1 is 1 and all the others are 0. So go ahead and put x1 to be 0 in your course pack. I know there's a kind of a typo there. Just put beta 1. Here. And then for business majors, they're the reference variable, so there would be beta not plus 0. And for the other majors, we'll have beta 2, beta naught plus beta 2. And the PE majors will be beta naught plus beta 3. And the psych majors will be beta naught plus beta 4 as the model. And the epsilon is the error random variable, which we hope will be 0. When we approximate this with B0 and B4, we get that. So let's just kind of talk about what this means then. So beta naught is the mean response for the business majors. That's our reference group. So beta 1, because we're going to do beta naught plus beta 1 to get the bio score, beta 1 is the adjustment to the business major's mean in order to obtain the bio major's mean. Remember up here, the bio major is beta naught plus beta 1. So this beta 1 will be what we have to add on to it to get to its mean. Same thing for beta 2. This will be the adjustment to the business major's mean in order to attain the other major's mean. So beta naught plus beta 2. And then here for beta 3, I think you can get the pattern here, that it's the adjustment to the business major's mean to get the PE major's mean. So beta 3 is the difference between the mean for the PE majors and the mean for the business majors. Okay, and so let's go ahead and do it the old way on Minitab. The old way on Minitab would be that, okay, I've got gender, majors, and scores. In the old way, I would go to Stat, to Analysis of Variance, One-Way Analysis of Majors. I would have the scores as my response, and the factor would be my major. I'd go ahead and calculate it, and here's that little picture that you have on page 155. Your page 155 actually draws the actual mean of the three values. This one doesn't quite. And we see that here my F value is 3.37 with a P value of 0.026. We would reject the null hypothesis and say the means are different. Okay, so let's now use this for how we do this with regression. Well, first of all, we need to make indicator variables. So I'm going to go to Calc, make indicator variables, and I want to do it off of the major. So I'm going to get the 5 majors here. And I'm just going to go ahead and delete business. Not that I have anything against business. I like business. But I just don't want to get this in my way. So I'm going to make that a 0. So now I'm going to go ahead and do my regression equation. And I'm going to fit my regression model. My score will be my response. And my predictors, oops, will not be there. They'll be here. The bio, the major, and the major psychology. Again, just as a reminder, if this would be a business major because we have 0, 0, 0 across, the other one would be 0, 1, 0, 0, and PE would be 0, 0, 1, 0. So that's kind of how I'm using my indicator variables. I have 4 variables because I have 5 different categories. And if I go ahead and do OK, this would be my equation for my values. And now notice something funny here. If I do my analysis of variance, hey, my F value is 3.37 and my P value is the same at 0.26. If we think about it, we would have done the overall F test and said none of these add utility to the model. I'd calculate my F value as 3.37, my P value 0.026. I would reject that null hypothesis and therefore conclude that there is some utility, and so one of those betas add utility, and so one of those means are different. It's really kind of an amazing way of doing these things. So again, it's the same. Now, the question you might ask is, well, why not I just use Minitab's Oneway ANOVA? Well, you have more flexibility with indicator variables, and it's more practical. So in other words, you have fewer tools, more experience with it, and more capabilities with the indicator variable method and the linear regression method. Now we can answer the means do differ by how much. And so that's going to be quite a ways, and we can use some other things by the partial F test and whatever. So I hope you get a glimpse here of using the indicator variables and using linear regression to help us out to decide, answer some questions whether or not the means are equal across several categories.